going to be using this mic?
I'll just use this one.
Okay.
So hey everybody, who is familiar with Kubernetes? Raise of hands. Okay, I see 1 or 2 hands out there, that's good, good start. Now, who here has done anything with observability? Does that term ring a bell? I see 1, 2. I'm very glad to see those 2 hands up. Anyone else? Alright, well in that case, let tonight be an introduction to a pretty critical concept that you'll probably run into fairly soon. There you go. So who am I? I was just introduced, so I'm not going to bore you by saying this all again. My agenda is very quick. These are the 3 topics that I'm going to go over. The first one is, what is observability and why should you care? Seems pretty appropriate for this room. Then we're going to talk about some observability and monitoring tools. And then I'm going to go through an example troubleshooting flow that just shows all these different tools in action. So because we're at Oracle, and we just found out that Oracle offers, or was the first company to offer bare metal cloud services, here's a very quick spiel on some of the stuff that sets apart Oracle Cloud from the other vendors. I'm not going to run through this right now, but one thing that I will draw attention to is that we do have a managed Kubernetes solution, and also a Docker v2 compliant image registry as well. So feel free to poke around with the free trial that we have up on the board. All right, so diving right in, what is observability and why should you care? Well, putting this into context, we are looking at a lot more microservice-based deployments than we have in the past. I'm not going to give you the usual monolith versus microlith spiel or microservice spiel, but just keep in mind that there are differences between a monolithic environment, let's say one big jar file, and a bunch of decoupled applications, which are probably distributed across environments, which are typically container-based. That's the new primitive of choice. They're very often polyglot, so it might not just be a Java application, but there might be components that are Java, Go, Python, etc., all depending on what's most appropriate for that particular part of your application. They're typically designed to be highly scalable, and especially in the Kubernetes world, they're all very ephemeral. So you might have one part of your application that exists as a pod in a cluster, and poof, it's gone. So you have to keep all this in mind when you're doing your development, and also when you're doing your troubleshooting. And with this new context, there comes new challenges. Latency is a big issue. You need to understand how things connect to one another, especially because everything's been decoupled. And that makes it very difficult to pinpoint issues. If you had, maybe one thing that has a slower request duration than you expected, if you have it pinging between 15 different microservices, how do you know where that latency is coming from? And also it makes it difficult to perform root cause analyses as well. So diving a little bit into the differences between previous RCAs and current ones, you're going to need to be able to continue to debug novel problems in your production environment. You also need to have an environment, a corporate environment, in which people feel comfortable testing hypotheses. You're going to run into different issues than you have in the past, and one of the core tenets of observability that I'll talk about shortly is actually having a tolerant and accepting culture where people feel comfortable being the one that did something wrong. So they refer to that as a blameless culture. There also needs to be data available to explore when it comes to troubleshooting. It's also important to document all these issues as you come across them, because you're not just going to come across them once. This information is going to be useful in the future. And the goal here is to address all of these issues that affect customer satisfaction. At the end of the day, if you run into a problem, the person who is most impacted by that problem is probably going to be your end users. And again, when you perform these analyses in a quantitative way, using the tools that I'm going to talk about shortly, they can help you prioritize things and also make justifications to the business to get more developers or more resources pointed at particular projects. So what is observability? Well, in a nutshell, it's designing and operating a more visible system. It is a system that allows you to understand it without the need to develop additional code, or to deploy additional code. So especially if something has taken place in the past, you can't always deploy a sidecar after the fact to grab logging data. You want to make sure that your system was built up in a way in the first place that you're collecting that from day one. It's about understanding different elements of your environment and also their relationship to each other. And fundamentally, it's also about explaining the variance between things that are going right and things that are not going right. Another key part of observability is also just the acknowledgement that regardless of how much effort you put into your system, systems are going to experience failure. And this is something that you can never really anticipate for everything. So as a result, you want to be able to test your system in a realistic way to prepare for as many different failure modes as possible. You need to be able to monitor external outputs. That includes metrics, logs, and also trace data. And also within observability, it's the idea of taking a holistic approach. So when you have a database go down, it doesn't just impact your IT teams, it impacts everybody from the support teams to sales, to other people who have to respond to different sort of service level agreements you've made with your customers. And as part of debugging that or troubleshooting, it's also a matter of having cross-team collaboration. So I know, working in Oracle, we have a lot of different organizations managing a lot of different facets of this process, and I end up having to coordinate cross-functionally with people that are in sales or in support, so that if there's an issue facing one of my customers, they know that they're being well attended to. And again, the last tenet here is just developing a blameless culture. So sort of under the umbrella of observability, you can find tools like monitoring. If you just monitor your environment and you don't adopt a lot of those other tenets of observability, again, the blameless culture and cross-functional operation, you have a bunch of data, but not necessarily the approach that you need to take the most advantage of it. So when it comes to monitoring, it's really focused on the external outputs that you get from a well-instrumented environment. And that includes logs, which of course are just a record of an event that takes place at a particular time. Also metrics, which are just numeric aggregations of data. And also traces, which are a little bit more important in a decoupled microservice-oriented world, because those are the things that capture the hops between services and allow you to pinpoint where exactly in your environment an issue is taking place. Put another way, monitoring tells you whether a system's working, and observability lets you ask why it's working. So one approach to observability is what's called the SRE approach. This is site reliability engineering. This is something that came out of Google in the early 2000s, and it's really just focused on operating these big systems at scale. Within the umbrella of SRE, you'll see terms like SLIs, SLOs, and SLAs. And what those refer to is basically just being able to define the metrics that matter most to the business, set some ideal values for those metrics, and then also define what our response is going to be as a company when we don't meet those ideal values. These are things that are pretty important to keep in mind. And again, when you're taking that holistic approach, it's about working with the different teams to make sure that your customers are having the best experience possible. Another key part of the SRE approach is what's called MTTF and also MTTR. That's just mean time to failure and mean time to repair. So it's the idea that you are increasing the amount of time that it takes between failures and decreasing the amount of time it takes to get up and running after failures occur. So all of these things, they can be quantified, and quantifying them can be really challenging. So just a little bit of advice up top here. Having no SLO is not great. Having a good SLO is good, and having a perfect SLO is a goal, but it may not be something you ever really can accomplish. So it's a matter of iterating over time. Also, it's important to keep these events in context. So really our ultimate goal is just user satisfaction here. So maybe users are okay with an occasional 500 error from the server. Maybe they're okay with things getting a little bit slower through retries if it means they're going to get through eventually. It's really just a matter of trying to figure out what the real impact is to the business. There aren't perfect thresholds, but again, if you just keep them in the context of what users are experiencing, that's a great place to start. And one piece of advice that I've heard is just trying to capture a window of time of positive events over something like 30 days, and then using that as the place to start from. So a good SLO, contrary to popular belief, barely keeps users happy, and it's the idea that you can have something called an error budget. So instead of investing all of your time in making sure the system is perfect, you can still allow some innovation in your organization. You don't have to force all of your resources onto just keeping things the perfect way for your users, because your users can tolerate refreshing the page a couple of times. And again, it's the idea of picking an objective and iterating it. So it doesn't have to be perfect the first time, but eventually you'll get to a closer approximation of an ideal SLO, SLI, or SLA. So that's me up on the hill, trying to give the spiel for why observability is important. and hopefully you've taken something away from that and might consider having a more observable infrastructure in your future. Now, segueing into observability and monitoring tools, we'll dive into sort of those external outputs, so again, logs, metrics, and traces, and some different tools you can use to capture them. So logging is really the most fundamental of all of these. In fact, traces and metrics are really just different types of logs when you really think about it. Logs are supported by most libraries. They're very easy to add to applications. I'm sure all of you out here who have engineering experience have probably added logs to your application. But one thing that's important to keep in mind is not everybody does, so you have to have the discipline to be somebody who adds logs so you can actually do troubleshooting in the future. One thing that's important to keep in mind is that if you don't have a method of capturing logs over time and holding on to them, they're just going to disappear as well. So it's important to have something like a log aggregator to keep track of those logs over time so that you can perform a root cause analysis and a retrospective so you understand why errors occurred. I'm going to show an example application later, and in that case I chose a Java logging class and also logging.properties config file, and they're just writing the standard out. So as I mentioned before, logs are only useful if you can actually hold on to them. FluentD, which we just found out was the most recently graduated project from the CNCF, is one of those tools that is great to capture logs in an ephemeral Kubernetes environment. It's just a log scraper and log forwarder. So all it does is scrapes from your application, looking for standard out logs, and then ships them to an aggregation tool like Elasticsearch, which is just a persistent data store. You can, rather than querying that data store directly, you can go through a tool like Kibana, which is just a visualization tool that makes sense of the data that you have stored in Elasticsearch. At the end of the day, I'm not necessarily advocating for this, which is typically referred to as the EFK stack, but it's just important to choose a tool that allows you to capture and analyze logs. So segueing into metrics, like logs, capture data from your environment, but the major difference is that they're numeric, which means, and they also are measured over time, which means they're more easily queryable and also easier to set alerts on. They're very easy to store and model because it's over time. You can crunch them down a little bit smaller and there's less overhead. And they're great for understanding typical system behavior. Most libraries these days, of course, support metrics collection. And in this case, all I did was use a Java metrics class that pushes it to a /metrics endpoint, which is where tools like Prometheus scrape from and then aggregate into their database. Prometheus, I think, was actually the second project to graduate from the CNCF. If you talk to anybody who's working in the space, they're pretty familiar with this tool. Basically, it's just a time series database. It allows you to capture that metrics data, and then other tools like Grafana are used to visualize that data. So just like we saw with Elasticsearch and FluentD making use of Kibana for the visualization component, it's important to actually have a tool that allows you to interact with the data that you're collecting. If any of you are familiar with Prometheus, writing PromQL, which is their query language, is a major pain in the butt. It's not very fun to do. It's a little bit confusing. And tools like Grafana just simplify that whole process. So I would recommend taking a look at that. One thing that's also worth mentioning is that vendors, including Oracle, will typically have an internal telemetry service that allows you to get data from the underlying resources in your environment. In Oracle's case, it's called the monitoring service. And what a lot of vendors have done is created plugins that allow you to take the data from a telemetry service and ingest it directly into Grafana. So it's very cool because you can actually model a lot of different data sources on the same page and create helpful visualizations or alerts based on the data that you get from there. It was actually my team that built this, so I'm pretty familiar with this one, and it's useful because you can have stuff like request durations that are captured by Istio on the application level on the same dashboard next to a different graph that's modeling telemetry data from the underlying infrastructure. And as I mentioned before, when it comes to metrics, they're also very helpful because they are capturing typical system information over time to create alerts. And alerts are probably just going to be something like, my system's not working well, hey, take a look at this. So as it says here, they're really just notifications indicating a human has to intervene, and that's just in order to make a corrective action. They're really very well suited to trigger alerts, and Grafana can actually be used to create those alerts. So Prometheus has a built-in alert manager If anybody here has tried working with it, it's not the easiest thing to do. Grafana makes it a lot easier, and you can do things like create a webhook that will take your alert or an alert event and then send it directly to something like Slack, informing you to take a look. And in fact, that's what I did in the demo that I'll show later. And as I mentioned before, the sort of newer part to this triumvirate of external outputs is tracing. And so what tracing does is just captures a request flow of causally related events that are part of a distributed environment. And so what I mean by that is, again, you're not looking at one monolith. There's not just one source of error to look through. There are all of these dislocated, disconnected parts of a microservice application, and it can be tough to figure out exactly where something's taking place or breaking down. So what's nice about tracing is that it basically will show you the structure and path of the data pinging around an environment. Each request that's made into your environment, maybe something like a REST API request, is going to have metadata inserted to it, and at each hop, which is referred to as a span, an ID is passed along. And what's helpful about that is, again, it allows you to see how that trace goes through a system over time and where things like extra latency are being introduced. There are a bunch of tools that are really good for monitoring tracing. There's a library now called OpenTelemetry. There were two major tracing libraries. There was Open Tracing and Open Census, and they actually merged back in June to form the Super Duper Tracing group. And so that's the one that everybody's standardized on. As far as tools that allow you to look at tracing data, the two main ones are Jaeger and Zipkin. And what's nice about them is you can actually just plug and play because they both use the same OpenTelemetry on the back end. Now, the last tool that is helpful when it comes to observability is a service mesh. Service meshes are great because typically the way they work is you're just adding something like a sidecar proxy to all the different parts of your environment so that they're more aware of how all the different components are connected. A service mesh, by definition, is just a configurable infrastructure layer for microservice applications. And what's helpful about them is they can be used to control east-west traffic between different things in your environment. So whereas you would probably use something like an API gateway or an ingress controller to control north-south traffic, this basically allows you to better coordinate how everything is going sort of under the covers when it comes to the different microservices you have deployed. What's cool about service meshes is they make it very easy to do things like configure blue-green environments or canary deploys and do other things like failure injection. So I'll show later that in my application, I just added a particular type of request call that injects about 1,000 milliseconds of failure, of latency. But what's nice about service meshes is you have such control over east-west traffic management that you can do things like inject failures or inject latency without having to do any sort of application rewrites. And as I mentioned before, they use a sidecar pattern. And as Owen talked about, it's literally just another pod, another container that's deployed alongside the pod you already have running. So service meshes also are helpful because they simplify things like tracing. You don't have to do the same sort of application rewrite that you would to add tracing to an app. They can track all the different hops in a request. Istio, which is the service mesh I'll talk about today, is one of, I suppose, three major options that I usually see. So Istio is a big one, Linkerd2 is another one that's coming up, and then other people will just use the Envoy proxy as well, and some folks use Consul too. Istio is helpful because in this case, since we're talking about observability, it actually comes out of the box with a lot of the different tools we just talked about. So you can basically just check a box on the Helm chart and deploy Grafana, deploy Prometheus, deploy Jaeger, all those things without having to do any extra legwork on your end. What's also nice is they have a bunch of sensible sort of default dashboards. So if you're looking for a little bit of assistance when it comes to creating your first dashboards, Istio comes with a lot of them pre-populated.
Can I just ask a question? I know it's not a question.
Sure, yeah.
But you said that it could identify those things without changing the app. How does it do that?
So
does it bytecode instrument or does it look at network?
It's looking at the network.
Okay.
Yeah, so it basically just the Envoy proxy is deployed as a sidecar on all the different components of your architecture.
Right.
And so literally all it's doing is just keeping track of the traffic that goes through those proxies.
And if you're SSL encrypting that, you give it?
Yeah, so it actually, Typically, people actually will use service meshes for like SSL encryption or just sort of neutral TLS.
Okay.
Yeah.
Thanks.
And then, as mentioned before, the reason I'm talking about service meshes is because they contribute to this overall concept of observability. So again, if you deploy microservices in your environment, you may not know how they're all connected. You may actually end up deploying something that's not connected to the rest of it and not even realize that. So what's cool about Istio in particular is that they have a tool called Kiali, which is literally just a dashboard that allows you to visualize the relationship between all those different microservices. And it looks a little like this. So in this case, this is an extremely simple application. This isn't multiple microservices deployed. This is just one app written in the Helidon framework, which is just a microservice way of writing Java applications. And so it's not the most fascinating diagram, but the idea here is that you could, if in theory there were multiple components of this, see the hops between each application. Which is a good segue into the sample app. So the app that I built to test this out is just built using the Helidon framework. As I just mentioned, it's just Java libraries for building microservice apps. There are similar ones out there like Spring Boot, like Micronaut. They're basically just tools that enable people to take commonly used Java applications and rewrite them for microservice type architecture. In this case, they're really just a handful of relevant components. So there's just the main.java, a RESTful greetservice.java, which is just going to help make these requests, and also a Kubernetes manifest file I used to deploy it to my cluster. In this case, it is instrumented for tracing. There's also health checks, so if I wanted, I could do a readiness probe. And also there's a metrics instrumented as well, and I have included some logs too. And in this case, it's deployed on top of Oracle Kubernetes Engine, but it could be any Kubernetes cluster. And I do have sidecar injection enabled, so I can look at it in Istio. So what does it look like? It's pretty simple. Basically, it just looks like this. I have the Chrome developer tools up here, so you can kind of see what it looks like. All I've done here is just, added something where I'm effectively making a request, like a put request, adding my name to this, and then also at the bottom, you can update the greeting as well. So, sort of tying all this together, we're going to go through an example troubleshooting flow. In this flow, imagine that I have an SLI, service level indicator, tied to request duration. And the objective for that indicator is I want to make sure that all of my requests happen in under 2 seconds. In this case, I have the same application I just showed, which is instrumented for logging metrics and tracing. And I also, in my cluster, have Grafana, Prometheus, Jaeger, Istio, Kiali, Elasticsearch, Fluentd, and Kibana configured. And I also have a request duration alert rule in Grafana configured to push to my Slack via webhook. All right, so this is what it looks like when it's working. And I also could just do a live demo, but I have all these screenshots, so I might as well. So all I could do here is just, I'll type in my name, Mickey. I'll click enter name. It says hello, Mickey. I can update the greeting on the bottom, change it from hello to hi or hola or whatever I want. It'll update the greeting. And then if I click enter name again, it'll just say hi, Mickey. So again, very, very simple REST requests. Within the application itself, and you probably can't see this super clearly just because it's a little bit far away, but I've also added something that's called a slow greeting. So for this request handler, we're introducing a little bit of latency into the request. In the front-end UI version, I'm only using the top one, which is just this normal greeting endpoint. What's also worth pointing out a little bit further down the page is you can see the delay that I've injected there, so just 1,000 seconds or 1,000 milliseconds. And I've also added a log, which is you made this request slow on purpose. So at the end of this, we're going to try to find that log in the system. All right, so right here, all I'm doing is just curling, and I'm curling the slow greeting endpoint. And all I've done is just adding the greeting hi, and it's returned that. And because I chose the slow greeting instead of the normal greeting, now my Slack is getting an alert notification. So right here, I see an alert, and I set, if the request duration alert triggers, it gives me a little note at the bottom that says, please take a look at the request duration times. What's nice about that Slack that I just got is that it allows me to have a hyperlink where I can jump directly into the Grafana dashboard that triggered this alert. And I can click here and I can see that I had a pretty major spike. So suspend disbelief, imagine I'm doing this live, and what I've done is basically just hit that slow greeting handler like 15 times over the course of a few seconds, and we're seeing this horrible spike where instead of greetings taking, half a second, they're all taking 2 seconds or more, which is way above our SLO. So what I can do now is just take a quick look at the timestamp there, and again, this is a time series database, so I'm capturing all the different metrics timings, and it looks like at about 4:15 or so, or 4:18, this is when that started occurring. So I can jump into Jaeger, which I also have in this environment, go to the particular service that I'm looking at. So in this case, it's an application that's in a pod called Quick Start SE in a namespace called Observability, as you can see in the upper left-hand corner. And I can see that I have these traces that are all taking an incredibly long amount of time. It looks like 2 seconds. So if I click into one of those, I can again see the timestamp, I can see the sort of cluster, and I can pick any of those and then use that same data in Kibana to try to filter out where my log is related to that error. So in this case, all I'm doing is filtering based on the pod that I see is having the issue and the namespace that was having the issue. And I can jump down to my log, and then again, within that time frame at about 4:16, I can see a log that says you made this request slow on purpose, which is the same log that I instrumented in my application in the first place. And because I know that log is tied to me making a slow greeting, I can go in and not make a slow greeting, and it'll return normal. And then I can see right here that Slack is updated with a new everything's okay on the request duration alert warning. So obviously, this is a very simple example from a very simple application. It wasn't 15 interconnected microservices or hundreds of them. It was literally just one microservice that was instrumented for all these different things we talked about. But you can see how something like this could be extrapolated to a more complex use case. In this case, one thing that would also be useful is having this connected to something like a ticket queue. So I could say, hey, whoever's responsible for this Quick Start SC service, can you take a look at this? Can you, help out with the logs and help us debug? But again, the idea here is basically just going through some key tools that can make it easier to start out with observability. So some key takeaways, observability is not just monitoring, it is taking a holistic approach to operations. It's making sure that all the different all the different parts of your business are involved with the process of keeping customers happy. It's also something that gives you maximum visibility into your environment. It's making sure that you're not gonna have to add some sort of tool after the fact, but that you have everything up front that allows you to capture the maximum amount of data, or at least relevant data, so you can troubleshoot in response. It's important to gain insight from logging metrics and tracing, and that allows you to discover issues, pinpoint their locations, and then sort of determine whatever the fix is required to make sure that they don't happen again. Also part of observability, we didn't really talk about proactive testing, but that's something that's really important as well. And again, because it's not just looking at the effect on the IT group within the business, it's a matter of recognizing the impact to the business as a whole and then planning accordingly. Cool, that's all I got. Any questions?
Another one.
Yeah.
What if, so this was a good talk, thank you, very good talk. What if one of your calls is a JDBC call to a database?
You're bringing databases in.
Well, I mean, knowing where we are and knowing that the world sort of lives and dies by persistent stores, a lot of them which are JDBC databases, right? Have these tools sort of enhanced themselves to be able to track that as a call?
So that's a really good question. Anytime somebody talks to me about stateful anything related to Kubernetes, I get a little bit nervous. I mean, people will do things like persistent volume claims, and that helps make things a little more stateful. In terms of capturing things like JDBC calls, I don't know if that's something that you could do with a service broker that would expose something that was outside of the cluster, or if you want to do something like incorporate a streaming service.
Like if your app or a shopping cart,
yeah,
ultimately, authorize their credit card,
Yeah,
and, save the order into a database,
yeah.
and the database were slow in responding to the persisting of the order, would you not be able to see that with?
Oh, as part of the rest of the environment?
Yeah.
I suppose it depends on how it's deployed.
Yeah.
I personally haven't tried doing that before. If you had it deployed like a container, like everything else.
Well, no, the database won't be a container.
Okay,
but
it would just be something that's pointed to.
The thing running in the container would
Point to the database?
Yeah. would-
Gotcha. No, it's a good question.
Yeah.
You can do things like run some of these sidecar proxies that like outside of the environment, but I haven't seen a lot of sort of mixed deployments like that. It's a good question.
What's your take on managing all of those subcomponents of those tools? As somebody that
Yeah.
has to administer all that, I mean, that's a lot as the environment, as this ecosystem is moving very quickly. For any sort of administrator or an observability engineer, really look at something and go, oh man, I gotta upgrade that.
Yeah, no, that's a really good question. So the question was, what's my take on, I guess, using hosted versions of that solution or just the management overhead from using all those different tools? I literally had a customer ask me that yesterday, and it's because they got really tired of managing their own Elasticsearch database. Yeah. So I would say a lot of the different cloud providers are offering hosted versions of those. We have basically hosted Prometheus for you, and you would just connect that to a Grafana dashboard. There's also a logging tool in the works. I know Google has Stackdriver, which gives you access to all that data. I think there are a lot of viable options when it comes to that. Obviously this is an open source presentation, so I'm trying to show people can roll up their own. But I think that there is, at the end of the day, it can be a lot if you don't have a specialized team or extra people managing all these different components.
So if I'm interpreting this right, so if you're tired of it,
You can pay somebody else to do
take
it.
somebody else.
Yeah, exactly.
Okay.
Yeah, Stackdriver is going away. They're moving to another solution.
Really?
I talked to them maybe a few weeks ago.
Oh yeah?
We have a customer in GCP, and so we wanted to log some of the stuff that we have to pass. That's not going to work. So, especially because they don't support standard syslog
Mhm.
kind of stuff, and it's just a nightmare. So they're going to shut down that project and moving to a new one.
Nice.
Can't remember the name. I have to look it up, but they're moving to a new one. So some of the stuff for commercial one, you can use Splunk.
Yep.
So
Splunk or
it's,
Datadog, I mean, there are a lot of
so
different
there's
options
a lot
out
of them
there.
out there, depends on what you're looking for. Sysdig is another one, right? But they're all up there, so you have to look at which one will fit better for.
And even tools like Grafana are trying to expand their scope so they're not just capturing time series data, but they also have like a logging solution that they've rolled out. So certain things like that are probably going to limit the management overhead because you'll still be just going to one tool that captures all the information you're looking for. Yeah.
So first, thanks for the talk, really
Yeah, no
nice.
problem.
Two questions. First one, how could I use this to measure, let's say, async tasks? So imagine I'm a client, you're a server, right? I made a request for you.
Mhm.
This request is super fast, but the heavy load is being done in, say, in another microservice in my Kubernetes cluster.
Yeah.
That is actually performing, let's say, a hype operation. So how can I measure this time?
So in that case, do you have a real need to measure how long asynchronous calls are taking?
Yes. For
Okay.
example, real use case, right? I work for G Healthcare, right? So in healthcare, it's very common to do like CMove and CStore and all of those like transfer between the different healthcare providers, right? And this is a very costly operation. So I want to guarantee that, like, let's say, for 100 CMove operations, at least 99% of them complete in less than, let's say, 2 seconds. How I measure this?
I mean, I would say if you were using something like a service mesh, you could keep track of that traffic. If you
Because
had it on
this-
each one of the different components.
Yeah, because this action is actually outside of the request, right? I mean, the request ended.
Mm-hmm.
But it has to go through the service mesh.
Yes.
So you will have track of all whatever goes in and out.
Okay. And another question, more like in a healthcare work, right? Cloud is super nice.
Yeah.
But go to the hospitals and say this, like, majority of them say, okay, this is cool, but I don't care. I mean, I have my system running since the 90s, and I wanna make sure that the sync is running, right? So essentially they say, okay, if you wanna put like a Kubernetes cluster running here with all the components,
Mhm.
you are fine. But then you need to guarantee that like, this thing only runs with those like hardware requirements, right? And my question is more alignment with his question. So there is a lot of like different tools which essentially can, increase the footprint of the overall deployment,
Mhm.
right? It's a bare metal like, deployment, like total offline. So how you see this? I mean, how is the footprint when you introduce all of those tools in the cluster?
So are you asking about like what's the performance overhead on these tools or just the
Yeah.
management
I
overhead?
mean, not a performance on the tool itself, but I mean, you are introducing like new containers, new pods in the cluster, right? So
Yeah.
I mean, how does increase your footprint, like when you look for the overall cluster point of view?
Oh, yeah, good question. So there are, I don't exactly know what the resource footprint for Istio is. There are, anytime you introduce things like sidecar proxies, there is gonna be a resource overhead that relates to that.
You are doubling each one, right? I mean, essentially.
Well, it depends. I mean, it depends on the size of the original container. These sidecars themselves aren't necessarily huge. I mean, they are just gonna be mediating traffic. And each component itself takes up some space. So there is a pod running Grafana, there's a pod running the tracing service, there's a pod running Prometheus. So there's gonna be some nominal overhead, but I have all this running on like a 3-node cluster, each of which is just one CPU, and the performance doesn't try too hard at all. So it's hard to know unless we knew exactly what the hardware specs are.
It all depends where you keep the logs.
That's a good point as well,
That's
yeah.
not really consume that much.
Yeah, so, but by the way, I mean, today I just deployed my first like EFK stack like 1 hour ago.
Nice,
Right?
okay.
Yeah, it's working. But then if you look at the Kubernetes documentation, right, they said like for logging you have like two approaches, right? Or you can go with an agent in the node itself,
Mhm.
like with Fluent,
Like with
right?
Fluentd, yeah.
Or you can have like a sidecar container for each pod,
Yep.
right? So for example, in Istio, can I have instead of like a sidecar container on each pod, I can have like just one agent that control everything, get a log of everything, and then I can reduce my footprint.
Well, in that case, I mean, the way that Fluentd is being deployed in this case is a daemon set, which is just effectively a node agent.
Yeah, but for Istio, I mean, it's a sidecar container for each one, right?
For Istio,
Yeah.
it is, yeah.
Is there any approach similar to the Fluentd as like a node agent?
I know that in the past, Linkerd 1 allowed you to do it on a single node basis, and I think you might be able to just install Envoy on the node itself.
Okay.
But typically, people do sidecar proxy model.
Okay.
So there might be another method out there, but not one that I've seen people do very often.
Is there any reason for this? I mean.
No, it's a good question. I don't know. I guess maybe availability.
Okay.
Also, I mean, as we saw, if you just have it deployed on the node, you're not going to get the same data that you would get from each pod having data sent from one to the next. So it probably wouldn't be able to capture traces in the same way that it would if it were just on the node level.
Okay. It's a kind of interceptor, right? I mean, each hop they will do in the cluster, like that sidecar container capture and log.
Yeah.
Okay.
Yep.
How do you see the legacy and monolithic applications and platforms fitting into this?
That's a good question. So I would say, as far as a general observability approach, there's no reason why legacy applications couldn't take advantage of this approach. I was just in a conference in Minneapolis last week, and we heard from one of the engineers who worked at Target about like a major issue that they'd run into there, and that was primarily focused on a monolithic application and not one of these new cool containerized cloud native ones. But they were able to take advantage of having that blameless culture, and they were able to take advantage of using these right libraries up front and making sure they captured all the data that was needed. So when it comes to general observability approaches, I think they apply to on-premise, cloud, monolith, microservice, all the same. It's really just a mentality. Things like DevOps are totally different, but I think for observability, I think it's okay. Yep.
So I missed out on first couple of questions. Sorry if I'm repeating the question. In a large distributed system where there are multiple microservices, and they are not directly talking to each other, but they are doing, they're talking to each other through other systems like workflow or queuing system or some persistent store. How can one use Zipkin to do the tracing distributed?
That was sort of similar to the database question.
Okay.
I honestly don't have the best idea of how you would do that.
Okay.
I'm sure there are a lot of engineers who have a better answer to that, but that's something that I can follow up on offline.
Okay.
Well, you know, one thing that we are doing, is we bytecode instrument the JVMs.
Oh, okay.
Now what I'm wondering is there a standard format that we could export the byte, you know, our output of that operation that these tools could make use of, right? In other words, if a JVM makes a JDBC call,
Mhm.
the JVM knows exactly what it did, it
Yeah.
knows exactly how long it took, right? And so if we could get it into some store like this, then that store could do the trending.
Right, you were
Yeah.
able to follow a ECID before that was,
Well, and you don't even need an ECID. I mean, if the, you know, if the damn thing reads and writes a file system, and the file system was the source of the latency, we'll know
Mhm.
that too, right?
Yeah.
So it's, you know, it's not just microservice latencies that slow you down, it's all kinds of stuff, right?
Yeah, very true.
It's the same scenario from the operations.
Exactly.
Yeah, the same.
Miki, I have a question.
Yeah.
I think on the beginning you mentioned about the OCI and the Prometheus, right?
Yeah.
They kind of work together. Can you elaborate more? What can you get from it?
Sure. So in our case, Oracle Cloud Infrastructure has a telemetry service, which is called OCI monitoring. Basically what it does is captures a lot of useful resource data from things like, you know, load balancer request tries or CPU utilization. There's a lot of different categories you can pull from. And what we did is we wrote just a plugin that allows you to, because there is Prometheus on the back end. So there's a plugin that takes the stream of API calls and translates them into something that Grafana can ingest. So then you can visualize all that telemetry data in the same dashboards that you are already using for the rest of your environment. Yeah.
Seems like the effectiveness of a lot of these tools depends on time syncing and making sure that all of your containers or pods or systems are getting their times from some kind of central server so you can match them up, and that's how they work. So do these systems inherently provide any tools to manage that, or how do you
To manage timestamps?
Yeah, syncing time across systems and machine clocks and things like that. If you're off by a few seconds, then
It could have a major issue.
traces are going to be way off. Right?
Yeah, that's a good question. Well, when you're deploying through tools like Istio, as far as I know, that mitigates a lot of the time issues that you might run into. If you're deploying them independently, I haven't heard that question come up before, so I feel like hopefully, you know, fingers crossed, it's a moot point. But that is a really good question about time sync.
the
So,
underlying systems
yeah, but-
so
typically have
there's-
NTP and things like that that keep
Yeah.
logging
Yeah,
across.
but you're
No,
also
but-
looking for times.
But for example,
Yeah.
go ahead.
Anyway, when I was deploying OpenStack, okay, so you have to have an NTP server that is basically in charge of that, because if there's an out of sync or you don't have it, it will not even install it right now. So you have, I'm sure if I recall it right, some of those require an NTP server in order to install it, because otherwise you cannot even go forward. So,
But
In my experience, I've seen even with NTP servers, actually, there was a situation where two VMs were talking to same NTP server, and one of them was generating a token which was out of sync with the first one, which said, "This is a token in future. I can't even understand this token. What are you talking about?" So you're right. NTP server is a good solution, but I've seen in practice where VMs are still going out of sync with NTP servers. So I don't know how to
that's
resolve
why the
that.
rule of 3 NTP server is not good. You have to have at least 5.
It's fine.
That's a config issue, by the way.
It is.
Yeah.
Because depending on your tolerances with NTP, you'll see if you actually probe that there will be a plus or minus.
Yeah,
From
this is
NTP.
strict or not, depends on how that's configured.
That's correct. And your drift level, it'll slowly drift, you can set it to slowly drift or quickly drift to keep in sync. So that's just.
But that's an
That's
end
all.
user issue.
That could be the issue. Maybe the default setting was too relaxed.
But in your example of the, like, for the FluentD, for example, FluentD runs as a demo set.
Yeah.
So which means that there is a guarantee that at least one pod will be in each node of the cluster, right?
Exactly, yeah.
So, and that FluentD is the central, let's say, aggregator of the logs. So no matter if all of those pods are out of sync, the main one that is producing the event to the Elasticsearch is the FluentD. So this guy is always with the same clock, right?
Yeah, but then you are on sync on other logs. You're going to have different data showing up all,
No, because FluentD, you stamp the time.
but the FluentD is stamping the time But if that server sends it to you 5 minutes later, you're going to have a different aggregation zone.
Yeah, that's true, yeah.
So that's not going to work.
Maybe Kubernetes does it magically.
I doubt it.
Yeah, that's a good point.
I'm just saying, put a cluster in the US and put a cluster in India.
And see if there's.
Oh, well, just wait, the
Yeah, just
magic will
test.
happen, you know, the magic will happen. It gets crazy.
Nice. Any other questions?
So timestamp on that though for your problem.
Well, yeah, but his point is, like, suppose you get network partition, right? So you are, your point, right, like you can't get your logs, you know, like locally you're doing fine, but you can't get the logs to the aggregator, except for a delay, right?
So I work for a load balancing company, right? We
So
just
he
get
would know,
acquired
yeah.
for, from VMware, right? When we put the controllers, we have a 10 milliseconds between the controller, otherwise it's not going to work. Because when you do global load balancing, there's a prerequisite on that. Otherwise, sorry, it's going to be not going to work. So there's we're talking about milliseconds here, right? And if you have like 5 minutes, the entire chart is all over. So
Well,
it's not going to
and
work.
plus, if you make calls to microservices that you don't control,
Yeah.
then you can't, you
Well,
can't.
we do, in our load balancing, we do east, west, and north, south. And we can basically say, you don't talk to that microservice or not, so we have that availability on it. But even that is going to be really hard in order to make it work. With the sidecar or whatever canary you want, it's all going to be pretty much the same standard at that point, but pretty tough.
It can be tricky. I mean, a lot of our systems time sync to atomic time, and because as we're trying to aggregate the logs, sometimes we're even trying to get varying systems to control other resources based off of that timing. It can be challenging, but it is a pain in the butt.
Yeah.
So we have figured out ways to solve it.
So that load balancing, which was acquired by VMware, we have all that data that he was mentioning, whether it's going to be a networking issue or an application issue, we log out everything. So you don't even need TCP dump, anything like that. You just go through the UI and you click on it, tells you the IP address, where the network comes from, which one is the connecting port, which one is the source NAT, which one is the server backend, what is the issue, what is the file, if the file is missing, every single detail. And it's all through the load balancing, no agent required.
Which UI?
The load balancer UI. And it works in multi-cloud. You have one load balancer and it works, Google, Azure, we have it in every single cloud, OpenStack, VMware, so on-premise, off-premise. So you have one controller with the UI, you basically log in and say, I want to deploy application here. It's all API driven.
So you don't have to collect any logs from any.
No, it's all collected automatically from the controller. And if you want to store that data somewhere else, you can send it to Splunk and we stream it, so you can have like 2 months on the controller and then the rest is archivable on Splunk.
That's pretty good, actually.
Cool. All right. Well, I'm glad that led to a spirited conversation. I know I have some stuff to take a look at, so that's helpful. But thank you all for the questions and for letting me present.